Hey everyone, in this video we're going to go through questions 3 and 4 of the financial SAC. And if you did just watch the previous one, I did talk about the kids playing outside, which is always lovely to hear. It is Easter, it's Easter Sunday, so yeah, it's good to hear kids playing. So I will shut my window if it gets too loud because you probably can't hear it. Sorry, let me just, oops, gone too far. There we go. All right, so 1 and 2 were done in a different video. I'm going to do 3 and 4 in this video and then 5 and 6 in a separate video. All right, so Frankie wants to buy an apartment. So he's found 2 apartments he's interested in. One's worth $950,000, the other one is $860,000. To answer question 3, you're to choose one of the apartments. So just like the previous video, option A is on the left, option B is on the right. So you only did the answers for one of them. Just make sure you're consistent whether you're using option A or option B. So that was a pretty easy question. All right, moving on to the next one. Bank of Mentone has a loan with an interest rate of 6.2% per annum compounding monthly over a period of 30 years. Calculate the minimum monthly loan payment. All right, so straightforward financial solver question. It's a loan, so it's money coming to you, so that is positive, and PMT is what we're calculating. So the only thing that really changed was that principal value. So if it was option A, that's your answer. Option B, that's your answer there. The final payment for this loan will differ to every other payment. Calculate the final payment. So there's 2 ways you can do final payments. You can do the second last payment and do it that way. I do think it's easier just to calculate it this way, so that's why I've done it, but you should get the same answer. So here's our payment from the previous question. So remember, if you're making payments, they can only be to 2 decimal places, so that's why the final payment is slightly different. So this is what we're calculating, the future value. The negative 2.64 means that $2.64 is still owing. So our final payment, we just have to add that on. All right, and then if you did option B, it's also negative, so that means it's still owing. So it still owes $2.36. So we add that on. All right. So this question here was a pretty big question. I'll just talk about the option A. So option B is there, but I don't want this video to take too long. The working out is exactly the same, it's just different values. So for budgeting purposes, Frankie is factoring in a possible interest rate increase to 8.1% per annum. So the thing with mortgages is the government, and then they pass it on to the banks or the financial institutions, can change your interest rate, which is very frustrating. So often when you buy a house, you do have to factor in an interest rate rise. So just a fun fact, when I got my mortgage, it was 2.9% and it is currently around 6.5%. So it's a huge jump. So you do have to factor in an increase. And I do hope one day it goes back down. Anyway, enough about me. So if interest rates rise to 8.1% from 6.24% at the start of the 5th year, how much extra will Frankie need to pay over the 30-year period of his loan? So obviously we've done some calculations here, which we're going to use later on, but we need to first of all think about, well, what happens if it changes? So at the start of the 5th year is when the change is made. So for the first 4 years, we're going to be paying an interest rate of 6.24%, and there's our payment that we calculated previously. So here's our future value, and I've written in blue so it stands out because we're going to take that value onto the remaining 26 years. So remember, it's a 30-year loan. So for 4 years, we've got the interest rate at 6.2%. And then for the remaining 26 years, it changes to 8.1%. So this value in blue now becomes our present value. and we need to calculate the new payment. So we let that equal 0, and I get, and I've rounded it to 2 decimal places here. What's that, negatives? So you get negative, but it's negative because it's a payment. Whenever you're paying money to the bank, it's negative. Just with your principal value, I have done several decimal places, not rounded it to 2 decimal places. I have put down here in green what it would be if you did round to 2 decimal places. So just doing that in case you, and the same applies as if you chose the other apartment. All right, but we're, because it's with the same financial institution, you're not really taking the loan out and then transferring it somewhere else. Because it's kind of staying in-house, the only thing that's changing is this interest rate. You don't round to 2 decimal places. All right, so we need to know how much is being paid. So just like before, we do have to calculate the final payment, because if we're making payments of $6,128.22, we'll still have a little bit remaining, just like we did before, and that bit remaining is the $2.04. All right, so I'll just show you on the calculator, because even though I've got all the prompts there, let's just clear that. All right, so we've got 26 times 12. Our interest rate is 8.1. Our principal value, 796588. I feel like I'm making a phone call. 0.7264. And then our payment, remember it's negative because it's going to the bank, 6128.22. So it has to be to 2 decimal places because it's impossible for you to pay less than 1 cent. All right, our future value is 0 here because I was calculating the payment. Now I'm calculating the final payment. So I'm just putting 12 and 12. All right, so if I go to future value, so see that it's negative, that means it's still owing $2.04. So you basically get to the very end of your loan, so your final month, and the bank says, oh, you know, you got to pay your usual payment of $6,128.22, but an extra $2. All right, sorry, $2.04. I had to cut out some coughing I did. All right, where are we? So when we're calculating the difference, we have to go back and calculate the original amount. And because we know that this your new condition is going to cost more, so I put that first. So I'm just going to highlight from before. So we had 30 payments times 12 of the original payment amount. Right, and then plus the additional $2.64. So in purple is what we were going to pay if there was no difference in interest rate. And then in blue, we had, remember we had 4 years, so 4 times 12 times that original payment amount, and then things changed for the following 26 years, and we had this different payment, and then that additional bit on the end. All right, so that last bit, making sure you get everything there to actually do the difference. All right, question 4. Frankie has taken up playing golf on the weekend and has decided he would like to purchase a new golf cart that costs $25,000. For insurance purposes, Frankie has 2 options for depreciating the golf cart. So you can have flat rate depreciation or reducing balance depreciation. So construct a rule. All right, so it refers to a rule to represent each of the depreciation options where AN, all right, it has told you to use AN, so that must be used here, is the value of the golf cart in dollars after n years. So it does ask for the rule. So some people gave the recurrence relation. Doesn't ask for the recurrence relation, it asks for the rule. So just make sure that you know you've got to answer correctly whether it's the rule or recurrence relation. And then doing flat rate or reducing balance. Sorry, it's a bit glitchy when I do it here. All right, and then we had to plot for flat rate depreciation. depreciation. So reducing balance depreciation was already given to you. When I was plotting these points, my dots moved. So apologies that they're a little bit, they moved a little bit to the left, but I put the values there so you can see. And because it's flat rate, it should go in a straight line, not that you should join the dots. All right, and then part C, discuss which depreciation option Frankie should choose if he wants to sell the golf cart at any time over the first 5 years. So you can kind of see, well, obviously at the start they're the same, but the flat rate is slightly higher for the first 3 years, or 3 years after he bought the golf cart. So you'd use flat rate depreciation, and then from then on you would use reducing balance, because you want to sell. If you're selling something, you obviously want it to be worth more. I'm just going to show you quickly on your calculator how you can get these values. Whoops. So even if you couldn't do the graph, you can put these onto your calculator. So we go to menu, sequence, and then we can put them in here. I had other things in there. Let me just clear them. All right, so the first one is, and I'm putting in the recurrence relation, so let's go to explicit. So this is where you'd put your rule, minus n, and tick that. And then the next one, 0.8. Let me just flip my computer over, because sometimes it doesn't like me. There we go. I just may have written a 0 somewhere. 887 to the power of n times 25000. Both these rules, you should have the notes in your bound book. Just remember, with depreciation, it is 1 minus 11.3 over 100. So if you're wondering where the 0.887 came from. All right, so here's the values for the flat rate. So you can see that's what I've plotted. And then for the reducing balance. So you can make comparisons between the two numbers. So we can see they're worth the same amount initially. After 1 year, flat rate gives you a better value of the golf cart. And then same for second year. Third year, just slightly higher. What is that, by $3? No, $53. But then after the third year, reducing balance gives you more money. So if we were to graph them, let's see if it works. Are you going to work for me? Oh gosh. Okay. Why did you graph me? It's really annoying. All right, let's just try this. No, that's not going to work. Oh. Well, there we go, but they don't look too good. So let's just change this to 6. That might be a little bit, no, it's too hard to see. It's too hard to see. Sorry, I'm spending time on something. I'm just going to use the scale that we've got on here. What did we go up to? 2500. Ugh. Not that you had to do this, because that would be quite frustrating. Y I'm in. Alright, so I'm going to start Y at 0 and max at 30,000. This might make it a little bit easier to see. Alright, so you can kind of see the blue line is higher until we get to here, and then it goes below. You could also do analysis trace to get those values, but we got them on the table there, we don't need to. Alright, and I think that was it. Alright, question 5 and 6 are done in a separate video. Bye guys!